Good morning. Today I'll be having an overview on APRS. This is Shabar Vechlani, Q6GFW. Uh, so this session is mainly going to be my learning, sharing um, on how I got the APRS working at my end. And I think for many of you out there who are looking to getting started with APRS, maybe these learnings will help. So let's get started. So, APRS is an acronym for Automatic Packet Reporting System, right? So what exactly is APRS? It's a form of amateur digital communication, right? So the word to emphasize here is that it's a like the data is encoded in the form of digital communications, right? And on top of that, like the data is sent, the bits are sent in groups of packets, right? So in APRS, there are APRS packets which are being transmitted on the APRS frequency and are being received by the various APRS listeners on radio as well as on internet, right? So it primarily has three kinds of messaging, right? The first one is the usual one where APRS is thought of to be of broadcasting nature, which is like the fire and forget mode, right? So if you are using APRS in this mode, in this broadcasting mode, you are primarily broadcasting position. So you're working as a position beacon, right? Or you are broadcasting weather information, or you are broadcasting some bulletin message. So the word to emphasize here is that it is a fire and forget, right? What that means is if the packet is transmitted, the transmitter does not know if it has been received successfully by any of the receivers, right? It's like a broadcast kind of a communication, right? So but there are other kinds of communication, right? Like they have improvised the kind of handshaking, right? In which you can have connected mode messaging, right? Which are messages with a confirmation receipt, right? So basically, in this, when you send a message, you are the receiving party. When it receives the message successfully, it will send back a confirmation receipt to the transmitter, right? And using that confirmation receipt, the transmitter can confirm that the transmission was successfully received, right? So like one way in which this works is like a timeout kind of a behavior, right? So example, like you transmit the message, then you wait for a receipt to come, right? If no receipt comes in within a particular timeout value, you assume it was not received, so you again transmit. That is, you retransmit. You again do this process multiple times until you hit the max retry value, right? And once you have hit the max retry value, you abort, right? So this is how the connected mode messaging works. Again, it is like dependent on the application, the scheme which I mentioned, right, wherein it is this multiple retries and the configurable number of retries. That is what happens if you're using APRS using the phone application, right? Now, one interesting aspect, right, like when we said that this was a automatic packet reporting system, right? So all the APRS receivers, right, or the transceivers which are listening on the APRS frequency, right, when they are in the listening mode, right, they are listening for all the APRS packets being received, they decode it, and they categorize and display all the messages which have been received in the respective application, right? Apart from seeing it in the transceiver or the mobile application which you're using, all these messages from all the people across the globe, right, are also being aggregated online on a website called APRS5, right? And given the nature of amateur uh, radio communication, these messages are unencrypted in nature. So you can basically read out the messages being transmitted by anyone, right? So typically you don't want to broadcast any sensitive information, right? So in this APRS communication system, like we can consider like these are a network of consists of three kinds of nodes. Okay? So the first kind of node is the user node, right? Like these are people like you and me who are having a handheld or who are having a fixed station at home, right? And who are listening to and transmitting occasionally APRS messages. Right? Then there are digitbiters, which can which is again like a short form of packet digital packet repeater, right? So they receive the APRS packet and they retransmit the APRS packet. So these, like the normal repeaters, right, are meant to increase the range, but unlike the usual voice repeaters where the incoming frequency and the outgoing frequency are different, right? Here in APRS, they get retransmitted on the same frequency, right? And the third candidate over here, right, is a special kind of a distributor, which can be thought of as an iGate, right, which is like a repeater with having internet gateway access. So once your message reaches this node, right, it has internet access. So on the internet, it can basically pretty much travel anywhere and avail any service on the internet, right? So this iGate is what popularly enables the APRS IS, right? Which are like APRS internet services, right? Wherein you can have a particular service hosted on the internet, which is listening for APRS messages and will respond back with appropriate response, right? So apart from let's go over the message types. In the message types, like in the broadcasting side, we already mentioned like you could be broadcasting the messages and using apps like APRS5 and the other APRS map websites, right? You can basically trace the entire route which person is taking. Say example, you took this APR or you have an APRS transmitter while you're hiking or going somewhere or driving, right? Then you can have your position information broadcasted via the APRS transmitter, and anyone can track your position online, right? Like say your friends, your family, right? Apart from that, like say in an emergency kind of situation, you can use APRS to send a special kind of packet to a SMS service, which receives your APRS packet and can transmit a SMS to a phone user, right? There are like services for email. One is the basic email service, wherein you can send a short single liner email message, right? And then there's the W-Link 1 service, which is like the APRS link, which is enabled by the APRS link, and you can basically transmit the email anywhere, like in a format, like the subject, the content, and recipients, etc. Right? So from thinking from a point of view of emergency kind of communication, right? If somebody has access to APRS services, right, or APRS nodes nearby, then they can reach out for help. They can reach out for self-help by broadcasting maybe like getting the service information on the weather or something else, right? Or the satellite information. I mean, there are like various services which are there, right? I mean, so they can use the self-help kind of a approach, or they can call out for help, in which I think the SMS will be useful, right? As people are more likely to respond to an SMS than look at emails typically. Also, there are some services which also enable you to send a WhatsApp message, right? So there's a chance that people may look at the WhatsApp message more often than the SMS. So you have multiple options out there, right? So let's go on further. Let's try to understand this better of how APRS packet broadcasts, right? Sorry for that background cooing off my baby, but yeah, I think let me just calm her a bit and get back. Let's continue further, like just to understand this, all the participants in the network better, right, and how your message propagates, right? So let's go for the most common use case over here, right, like where you make use of a distributor to reach out for help, right? So in this case, your message will primarily go from the user node, right, to the distributor, and from the distributor, it can go to the other user, right, and vice versa. The path will be there when receiving the message from the user 3 to user 1, right. The other form which we mentioned, right, wherein you can avail the APRS IS services, in which your message via the distributor, right, like could be broadcasted further to reach iGate, right, and from the iGate it can go all the way to the internet services, right, and you can basically get any information, or you can send email, you can send SMS, WhatsApp message, etc., right. The third form is like if you don't have a distributor but you have someone actively listening on the APRS frequency, right, then you can uh, kind of message them directly, right, on the direct path. So in that case, right, like it will just be this direct path messaging, right, which will be received by the recipient by the targeted recipient, right. So these are the various ways in which your message can propagate, right. So let's go into the OSI model, like which is the communication stack, um, the textbook communication stack. So what I've tried to do is I've tried to map like where each of the popular terms related to APRS fits in this communication model stack which we have, right. So there are these application level programs, right, or softwares, which we primarily use to interact uh, or decode the messages and like interact with this entire system of APRS. And based on which platform you're working on, like there are different kinds of softwares available, right. So I personally have tried out these three softwares which have been listed here, right. So the first one is Xaster, right. So this is a software which you can use on Linux, right, and to send messages and to see the location on the map of where the various people are on the APRS network, right, because in the APRS all the participants, right, like whoever are using this these recommended softwares, they typically have to beacon their position, right, every I think every 10 minutes or so. I mean, you can set that thing like how often you want to beacon your position, right, and based on that you're hopeful to see like within say half an hour, right, you should be able to see who all are around you, if there are any people who are on APRS, right. So that can help you know like what activities on going on APRS near your place, right. There is another cross-platform software available, which is I would say compared to Xaster, it is more modern, which is called YAAC, which is like an acronym for yet another APRS client, right. This can be run on any kind of platform. As I said, it's a cross-platform software. Then we have the software called APRS Droid, right, which is available for Android, and it's very popular. It's very convenient to use. These are the three popular ones I saw. There are many more which you'll find on the internet. In my personal view, if you're working on Windows, you can make use of Xaster or YAAC, either of them, right? And if you're on Android, you'll make use of APRS Droid, right? On the data link layer, you basically are like doing the framing, right? So the frames in APRS follow the AX.25 framing format, which is the amateur radio variant of the X.25 framing format. And in this framing format, right, basically it like each APRS packet, right, will consist of like a particular formatting, right, and in that formatting you will mention the source, the destination, the path, like the routing path which you mentioned, right, then the kind of service which you want to avail, like which can be thought of the message type, and the actual message payload content which follows later on, right. So every message follows this format more or less, is what I have seen in my observation, right. Once your packet is framed, like this is still at a digital packet bit level, right, those bits are converted then into the physical layer, first into tones, into audible FSK tones, wherein like 1 and 0 is indicated by a frequency of 1200 hertz and 2200 hertz respectively. If you want me to show how this looks on the scope, comment below and I'll include the screenshots of the scope capture in the next video. And so this FSK tones are then modulated and transmitted at the carrier frequency of 144.390 megahertz. So the frequency of APRS, right, depends on the region, right? And in the United States, the frequency is 144.390 megahertz, right? So I found some interesting map on the internet, which I thought like is worth sharing, right? And let me just like quickly walk through this. So this map indicates the APRS frequency usage across the globe, right? And as you see, right, like most of the North America, right, or the entire North America is using the 144.390 megahertz frequency. But if you see in South America, right, if you see this Brazil Argentina portion, right, like you will see that the frequency which is used is 145.575 megahertz. If you see Asia and Africa, they are all, and Europe, they are all based out of 144.800 megahertz, right? And if you see towards Australia, they are on the frequency of 145.175 megahertz. So it's interesting that there is no single APRS frequency throughout the globe, right? And based on which region you are trying to access APRS, you will have to tune your handheld to appropriate frequency. Right? So here in US, you will be listening to 144.390. So I later on have a setup wherein how you can kind of access the APRS frequency in the different regions by using web SDR services in that area, and we can tune to those frequencies and decode and see the traffic and the activity across the globe. So hopefully I'll try to cover that in the second video, right? Let's go further, right? So as I was saying, there are various levels at which you can get a taste of APRS and what APRS is. In my view, one of the easiest way possible today is to make use of the web SDR service. There are more than hundreds of free web SDRs available, right, hosted by various universities, by various amateur clubs across the globe, right? So by web SDR, you can think of it as a radio receiver which is hosted at a particular site, right? But the packets which are received by the web SDR, right, all the data which is being received by the web SDR can be accessed using the internet anywhere across the globe, right? So you can log into a radio in Japan, you can log into a radio in Argentina, I can log into a radio in Europe, right? And I can see what is ongoing over there in the amateur radio, right? And this is like pretty fascinating, I found, right? And if somebody just wanted to get a taste of APRS, right, they can use this web SDR. The only caveat is that it is a RX only setup, so basically you will only be able to receive the packets, right, and see the activity. But still it is very good to kind of piecewise test and understand the various components and in the overall signal chain, which we'll discover in the further slides, right? So let's just walk through this. So say you pick any web SDR setup, right? So the web SDR setup will typically like allow you to pick a 3 kilohertz, 1.5 kilohertz, or like depending, you can set the bandwidth. Basically, given it's in the audio frequency range, right, and you can route that audio via a virtual audio cable, right? So this is a nice free software available using which you can route audio from one application to another, right? So this web SDR say is running on your Chrome, right? You can route it to this application Direwolf, which can understand those two-tone FSK information and convert and demodulate it back into the individual bits and the packets information, right? And then on the Direwolf, you can look at the individual packets getting printed, and you can get a sense of what traffic is ongoing. Further, you can connect that Direwolf to any of the popular softwares which I already listed, and get the map information and like all the other messages which are being bulletin message information, weather information which is being transmitted, right? Now this is the most basic way, I think, in which somebody can get introduced to web SDR setup. The next level setup is for someone who wants to do both RX and TX, but say they are in a home setup, right? So they are not, the radio is fixed, right? So say they have a handheld which is always at their desk, right? And they have like, how would they go about connecting, right? So what I have understood is, right, so say you take any handheld transceiver VFH radio, right? Because this frequency ranges, if you see, right, like everywhere is in the VHF range, in the 140 megahertz range, right? So you will need to connect this to a Direwolf kind of a TNC, is like a terminal node controller or a modem, right? which can decode that audio into the digital packets information and can render it on your screen, right? So what I make use of interesting adapter over here, right, is called an AOIC adapter, which is again an acronym for all-in-one cable, right? I think I have like it's an all-in-one cable, right? So it's a open source project. You can order this kind of an adapter online. I think I bought it for some $35, right? And it's basically just a sound card, USB sound card, with a push to talk control. So say on one of them, right, like you're transmitting the audio, right, and on the other one you're transmitting, like doing the push to talk switch pressing, right? So both these can be transmitted over the USB and controlled by Direwolf or any of the other softwares, right? So so one thing which I have realized whenever I'm working with a handheld VHF radios over here is, initially I was not able to get the uh, transmission working. Most of the time my USB port would give some error whenever I'm trying to transmit, right? And after googling a bit and checking with other amateur hams in my area, I understood that I need to make use of ferrites on the USB cable, so that the transmission does not get coupled back from the antenna back to the USB cable, right? So um, I got this snap-on ferrites from Amazon, and I just snapped them onto the USB cable, right? And once I had the setup in place, I was able to transmit and receive fine on Windows, right? Again, let's just get the setup first, and then we'll go into the demo, right? Okay, so the third one is a setup which I would think someone who is say going on a hike or remotely traveling, right, like will find useful, right? So in this setup, let us walk through it one by one, right? Again, there are like options like Mobilink D and other kind of devices which can function as TNCs already, right? But my approach has been trying to make use of things which I already have and see if I can cheaply get APRS working, right, in a practical way, right? So in this approach, the left hand side still remains the same, right? So we have the handheld transceiver. In my case, it's my Quanshank UVK5. Then I have my AOIC all-in-one ham radio cable, which is nothing but the sound card with PTT control. Then we have our USB cable with the snap-on ferrites. Now the Direwolf, which I showed earlier, which was running on the PC, we can run the Direwolf on Raspberry Pi as well. So in this case, I run Direwolf on Raspberry Pi, and then those packets which are there, right, those packets which are digitally there, to render them and to be able to kind of see them in a more meaningful format, right? I make use of the APRS Droid application on my Android phone, right? And the communication between the Raspberry Pi and the APRS Droid on my Android phone is done by Bluetooth, right? So on the transmit part, I type in a message on the APRS Droid, then that message goes via Bluetooth to my Raspberry Pi running Direwolf. It then modulates it, right, and sends the AFSK tones over the sound card to my VHF radio, which transmits it back on whatever VHF frequency I have tuned on my handheld. So in this approach, right, I could have my entire setup. Say I could have this VHF radio in my backpack, right, along with my AOIC cable and my Raspberry Pi, all of them like in a box in my backpack, right, with the antenna sticking out, right? And I can just have my phone in my hand, right, and say when I want to reach for help and I don't see any network bars on my phone, right, I can connect via Bluetooth to this service which is running on my Raspberry Pi, and then using that I can kind of send and receive messages on, like, avail the various APRS services if they are available, or reach out for help by exploring and scanning the nearby area and individually messaging and reaching out for help, right? So let me just quickly go over the software setup also, like, and some level of details. We already said that, okay, we have a AOIC cable, which I'm just calling here as the USB-C sound card, which is interacting with the Direwolf, which is our AFSK modem, right? And this AFSK, this Direwolf layer, right, it provides this various kinds of ports, and you can think of it like pipes available through which that information, the decoded packets, can be consumed, or the packets can be sent over to Darwolf for modulating and sending out, right? So what I've found is, and what I've used is, so when I'm using Exter and YAC, I use the AGWPE. I forgot, like this. The initial words are some the person who founded it acronym, and the PE is the packet engine. Okay, this is like a custom protocol, and it is given as a service on the 8000 port. And using that, I was able to use the Exter and YAC fine. Like in the next video, I'll show how to set it up. Then I have this thing called like the KISS interface, right? Which is nothing but an interface in which it sends this information in TCP/IP packet form, right, on this 8001 port. And this third one is what I ended up using finally, right? So wherein what I did is, in the APRS droid, I configured it as a Bluetooth TNC, right? And then I have another script, like the script functionality about like disconnecting and connecting, right? This is bt.darwolf.py, which makes use of that, right? And it handles that connection disconnection aspect, and connects it over to the Darwolf, right? So I don't want to get too technical. Maybe the diagram gives a high level overview, right? But if you have any questions, or if you want me to do a follow-up video with more details on any of these things, right, please comment in the section below, right? Okay, so I think the next section was demo time, right? So I think I'll take it over in the next video. So what I'm going to do is, if you want the link to the slides, you can message me, send me an email on shabbirvijlani@gmail.com, right? And I can share you the public link to the slides so that you can scroll over at your own convenience. If you have stayed so far, please give me feedback on what you think about this video style, and if you want, like, what all things you want me to go into detail. So because I've gone through this process over a period of 2 months to figure out everything and get it working, and I'll be really happy to help other people who have struggled to get APRS just like me, because actually, if you have the right pieces of information, you can get it working and get good confidence in using this wonderful service of APRS. So see you in the next video for the demos. Till then, take care. Sign off. 73 from KO6GFW.